In this presentation, I will go over the intent, implementation and impact of the maths curriculum at Mayville Primary School. At Mayville Primary School, we want our pupils to become fluent in the fundamentals of mathematics. We want them to know their number bonds, times tables, division and other number facts. We also want our children to be able to reason mathematically, to explain their answers or to follow a line of inquiry. We want our children to be able to solve problems by applying their mathematical knowledge. And we want our children to develop a passion for mathematics. We want our children to love mathematics. And the overarching goal is maths mastery. There are three main aspects of implementation: teaching and learning, assessment, culture and environment. As you can see, the statements have been color-coded to show you how they relate back to the intent. We will now take a deep dive into some of the main points in each category. The first thing we'll explore is maths mastery. The National Centre for Excellence in the Teaching of Mathematics defines mastery as: mastering maths is where pupils of all ages acquire a deep, long-term, secure and adaptable understanding of the subject. Now, the main point here is the adaptable understanding. What this means is that children have to be able to apply their knowledge in different contexts. And in order to acquire this adaptable understanding, they must be procedurally fluent and possess a conceptual understanding of mathematics. And this is what we are going to explore now. So the question is, what is procedural knowledge and what is a conceptual understanding? I think this is best understood through an example. So here we have a question: John and Karen share £35 between themselves in the ratio of 2:5. How much does John receive? Now, a child who possesses procedural knowledge may answer the question like this. Step 1, add up the ratios. 2 add 5 is 7. Step 2, divide the total amount, £35, by 7. You get 5. And then step 3, we want to know how much John receives. John's ratio is 2. 2 times 5 is 10. So John receives £10. Now, you can teach a child to arrive at the answer following a series of steps. But the question is, do they understand why they're taking these steps? And more often than not, the answer is no. Now, in contrast, a child who possesses a conceptual understanding of ratios may answer the question like this. The ratio is 2:5, so there are 7 parts in total. 7 equal parts. The total amount is £35, so the entire 7 parts represents £35 the total. £35 divided equally into 7 parts. 35 divided by 7 is 5, so each part represents £5, or each section represents £5. The ratio is 2:5, so 2 parts will go to John, and 5 parts will go to Karen. Therefore, John will receive £10 in total. As you can see here, the child understands exactly what is happening and why they are taking the steps. And this is exactly the type of understanding that we want to nurture. So to summarize, with procedural knowledge, a child knows how to arrive at the answer but does not necessarily know why. But with a conceptual understanding, they know how to take the steps and they know exactly why they are taking the steps. And often this manifests through the use of a diagram, and this is exactly the type of understanding that we want to nurture. Let us consolidate what we've just learned through another example. So here we have a question: after completing 2/3 of a race, Michael had 400 meters left till the finish line. What is the total distance of the race? Now the question is, what would a conceptual answer to this question look like? I want you to pause the video and have a go. Now, a conceptual answer to this question may look like this. We can divide the entire race into three parts, into thirds, into three equal parts. Michael has completed 2/3. And the remaining part is the amount he has left. It says here that he has 400 meters left till the finish line, so this last box represents 400, and because these are equal parts, the other boxes also have to be 400, and therefore the total distance of the race is 1200 meters. 400 meters, 400 times 3 is 1200 meters. Now we'll explore some methods and strategies for teaching for mastery. The first thing we need to focus on is the learning objective and the success criteria. Every lesson should have a clear learning objective, and the success criteria or the learning outcomes should be exhaustive and logically ordered. And I think this is best understood through an example. Imagine that your learning objective is to be able to add fractions. What should the success criteria be for this lesson if you knew that the students would have to answer these questions? I want you to pause the video and have a go at listing the learning outcomes. So based on the activity questions, the list of learning outcomes would look like this. I can add fractions that have the same denominator. I can add fractions that have different denominators. I can add fractions to integers. I can add fractions to mixed numbers, and I can solve a word problem involving the addition of fractions. Now, notice that the outcomes are becoming progressively more challenging, which is a form of differentiation, and that all of the different skills have been methodically covered. Now, why is this a good practice and how does it help students? Well, firstly, it makes learning more accessible because the learning outcomes are differentiated and things are becoming progressively challenging. And it prevents knowledge gaps because you are teaching the topic methodically in a systematic, logical manner. And also it provides a clear roadmap of the learning journey, which is more conducive to learning. The bar method and the CPA approach are integral parts of teaching for maths mastery. We will now see a couple of short videos from White Rose Maths that explain these teaching strategies.
Hi, my name is Jess Easton from White Rose Maths. This series of short videos will give you an introduction to bar modelling. Throughout these videos, we'll be looking at the basics of bar modelling through the 4 operations. You may have heard a bar model referred to previously as a strip diagram or tape diagram, but throughout this series, I will refer to them as bar models. So, what can bar models be used for? The main aim of a bar model is to give a pictorial representation of the underlying structure of a mathematical problem. This helps children understand and solve the problem. Bar models can be used to illustrate basic concepts and also to solve complex problems. In these videos, we will explore their use with basic concepts. In Series 2, we'll delve deeper into solving problems. Sabila Beckman carried out some research about textbooks and teaching methods in Singapore and published an article in 2004. She found that in as early as the 4th grade or year 5, children were able to solve algebraic story problems without any pre-knowledge of algebra. They used the bar models to expose the underlying structure, which gave them a way to access the problems. Bar models come in all shapes and sizes. Here are some of the most common examples. In this series, we're going to focus on the single bar model. If you want to find out more about the comparison bar model, check out our Learning Series 2. Can you think of why they're called single bar and comparison bar models? Over the course of the videos, we will see that some bars lend themselves better to certain problems more than others. A key misunderstanding of bar models is that they will do the maths for the children. This is not the case. What the bar model does is expose the mathematical concept, allowing children to more easily understand what calculation to perform. So we've now seen what a bar model is and that it can be a useful tool to help children understand basic concepts and solve problems. Before we look into bar models in more detail, it might be useful to take a look at the CPA approach to teaching mathematics, based on research from Jerome Bruner. So, what does CPA stand for? Concrete, pictorial, and abstract. Let's find out why it's so useful to take this approach. You may or may not know that our brains do not like abstract. Looking at a page of calculations or algebra to some can look confusing and cause people to think that maths is difficult. Often, these stages in CPA are presented side by side to give children a deeper understanding. Throughout the bar models in all of our videos, you will see the abstract calculation on the right. The concrete stage involves children using physical objects or manipulatives. The pictorial stage is the part where there is a visual representation of what is going on. It is important that children see the link between the concrete and the pictorial stages. The final stage is the abstract, where all the numbers and symbols are involved. This is what most people see as maths. Children who struggle at maths may do so because they don't understand the abstract. Using a CPA approach can help children visualize concepts, which leads to a better understanding of the abstract calculation. In the next few videos, you will see the full CPA approach in action. Bar models are part of the pictorial representation stage of the CPA process. You will also see how useful they can be in helping children understand what they have to do in order to solve a problem. It won't help them do the calculation. However, it will help them work out what calculation they need to do. As we have discussed in the last video, the concrete, pictorial, abstract approach to mathematics will help students learn and understand mathematical concepts. In this short video, we will look at how the CPA journey can be applied to a simple example of addition. You will notice throughout our videos, we present maths problems through a story or a scene setter. In this particular example, we're going to look at the amount of apples two people get. Let's have a look at the problem. Peter has 5 apples and Jane has 3 apples. How many apples do they have altogether? How could we model this? Well, as a teacher, I could demonstrate this using real apples or pictures of apples. Let's see how it would look. In the question, Peter has 5 apples, so we could model this with 5 apples and label them as Peter's. Jane has 3 apples, so again, in our model, we could have 3 apples and label them as Jane's. As a teacher, I have done something here that children may not have. Can you spot what it is? I've placed the apples in a line. This is a great point to discuss with the children. Why will arranging these apples like this help avoid miscounting? Going back to the problem, I want to know how many apples they have altogether. So to model this, I will draw a brace and add a question mark to my model. From all of this information in my model, I can see that I will need to add Peter's 5 apples to Jane's 3 apples. Although you might want to give 8 apples to each child in your class, this might be a little tricky. So a great transition to the next step of the CPA journey would be to represent these apples with something else. In this case, we've exchanged each apple for a counter. So one counter represents one apple. Again, this then leads nicely onto the pictorial representation of a discrete bar model, where all the parts are in equal size and have the value of one apple. Always ensuring that the calculation goes alongside the representation is a key point to keep in mind, so children can make the connections between the concrete or pictorial representation and the abstract calculation. Before you move on to the next video, reflect on this journey for your children and think about how could you apply a similar journey to a different concept.
Our school has a subscription to White Rose Maths online training where we have access to a course on bar modelling. As you can see here, this is a comprehensive 3-part course where you have video tutorials for that go through how to use the bar method and the CPA approach for every topic in maths. This is an amazing resource, so please contact me for your username and login. In order to achieve our intent, we have to be using a maths mastery scheme of learning, and that is why our school has adopted the White Rose Maths scheme of learning. As you'll see, this scheme of learning has the maths mastery approach embedded within it, and there is a perfect alignment between the schemes of learning and the assessment. Now, to access the White Rose Maths schemes of learning, all you need to do is to go onto the White Rose Maths website. This does not require a login. If you go to the Teachers and Schools section and then go to Primary Resources, and then here you'll see we have the schemes of learning and the assessments. If we click on the schemes of learning, scroll down, and this is where you'll find a long-term overview. I will use year 1 as an example. As you can see here, the scheme of learning has been divided into topic blocks. Now, it is important to note that even though the topics are taught in blocks, the White Rose Maths curriculum is a cumulative curriculum, so that once a topic is covered, it is met many times again in other contexts. So for example, place value is always taught in Autumn 1, but is revisited within addition, subtraction, multiplication, and other topics. Now, by clicking on a block, this is how you access the midterm plan. Looking at the midterm plan, you'll see that the maths mastery approach is embedded within it. When you scroll down, you will find the sequence of lessons that are called small steps. Now, for each lesson, you have a mini guide where you have some notes and guidance, some mathematical talk, some varied fluency questions, and some reasoning and problem-solving questions. Now, it is absolutely essential that you incorporate the mathematical talk within all of your lessons and give children opportunities to share their answers. This is part of our school's maths policy. Now, the difference between fluency questions and reasoning and problem-solving questions is that the fluency questions focus on a particular skill, whereas the reasoning and problem-solving questions are a synthesis of different skills used within the lesson. It is good practice to get the children started on fluency questions first and then transition them onto the reasoning and problem-solving questions. It is part of our school's maths policy that all lessons should contain some varied fluency questions and some reasoning and problem-solving questions, and you can see how this practice relates back to our school's maths intent. To supplement the White Rose Maths schemes of learning, our school has a subscription with Classroom Secrets, which provides resources that are perfectly aligned with the White Rose Maths schemes of learning. So I will use year 1 as an example here. So if we go to year 1, Autumn Block 1, you will arrive at this screen here. Now, if we go back to the year 1 autumn midterm plan, as you saw earlier, the lessons are sequenced in these small steps. This exact same sequence of lessons is found here. Now, if we click on a lesson, you will find interactive lesson slides, which you can play as a slideshow in your lesson, or you can download the PowerPoint and adapt it according to your needs. And you'll also find kid-friendly lesson slides that you can assign as homework on Google Classroom, just for the children to recap prior knowledge. You also have prior knowledge worksheets that you could assign as homework. You have some practical activities, and then here we have the main worksheets, the varied fluency worksheet and the reasoning and problem solving worksheet. As I mentioned earlier, it is a good practice to get the children started on the varied fluency worksheet first and then transition them onto the reasoning and problem solving questions within the lesson. Now, when you access the worksheets on Classroom Secrets, you'll notice that all of the activities have been differentiated at 3 levels: developing, expected, greater depth. So here we have the varied fluency worksheets, and as you can see, all the activities have been differentiated at 3 levels, and you have the answers at the end. The VF here indicates that it's a varied fluency question. If you look at the reasoning and problem solving worksheet, you have the same thing. All of the activities have been differentiated at 3 levels, and we have an R here to indicate that it's a reasoning question, and PS here to indicate that it's a problem solving question, and we have the answers at the end. Now, when it comes to differentiation, our school's expectation is that if you are teaching a mixed ability class, all activities should be differentiated at 3 levels so that all children can access the learning and children are being challenged at their respective level or stage. In addition to Classroom Secrets, all teachers in Key Stage 2 have been provided with a CGP Maths textbook that can be used as a resource in conjunction with Classroom Secrets. It all depends on the particular learning needs of your cohort. Now, if we look at the activities, as you can see, for every lesson or every topic, the activities have been differentiated at 3 levels. Set A being working towards the expected, set B being working at the expected, and set C is for children who are working above the expected or at greater depth. So what would a typical lesson look like? Here is an example of a lesson that I've planned using the available resources. As you can see, there is a clear learning objective and the learning outcomes are exhaustive in that they cover every skill that will be learned within the lesson. The learning outcomes have also been logically ordered in that they become progressively more challenging, and I have my keywords here. I have a starter and then I have mathematical talk. As I mentioned earlier, mathematical talk is a non-negotiable. It has to be found within all lessons, and I've just directly taken these questions from the White Rose Maths midterm plan. And then we have some varied fluency. Again, I've taken these questions directly from the White Rose Maths midterm plan. Some more mathematical talk, some varied fluency again, and then I have my main activities here. As you can see, the main activities have been differentiated at 3 levels in line with the school's policy. And then I have some reasoning and problem solving questions. Again, I've taken this directly from the White Rose Maths midterm plan. Some more reasoning and problem solving. And then lastly, I have a SATs question as my plenary to consolidate the children's learning. I will now go over the marking and layout expectations of exercise books from our school's maths policy. Pupils should do their work in pencil. In Key Stage 1, the learning objective should be printed and stuck into exercise books. In Key Stage 2, students should write the learning objective as the title and underline it. The date should be written shorthand. At the end of a maths lesson, the class teacher should highlight the yellow green if the pupil has successfully met the learning objective, or yellow if the pupil has not met the objective. So here is an example of a child's book from Key Stage 2. As you can see, the learning objective is the title, the learning objective has been underlined, the date has been written shorthand. At the end of the lesson, the teacher has marked the work and they have highlighted it green to indicate that the child has met the learning objective. A page margin is not necessary but may be drawn by the pupils at the discretion of the teacher. Worksheets may be stuck into exercise books at the discretion of the teacher depending on the activity or the developmental stage of the child. So for example, when teaching how to draw sectors in a pie chart, children should not be made to draw a circle in their exercise books. A worksheet should be provided instead. Activities in maths lessons should be differentiated at 3 levels, as we've mentioned earlier. Pupils' work should be marked on a regular basis using a green pen, a tick if it is correct, a dot if it is wrong. Pupils should be given time to revisit their work and correct their work using a purple pen. A response question should be given if a child has a specific misunderstanding. A next step question should be given to consolidate or extend pupils' learning, and in the next chapter I will go over how we draw this distinction between a response question and a next step question. Pupils should answer response questions and next step questions in purple. Work may be peer marked by pupils using a purple pen. Verbal feedback may be given at the discretion of the teacher. In this case, VF should be written next to the pupil's work, or a verbal feedback stamp may be used. Each year group has a key performance indicator sheet that needs to be stuck inside the front cover of all exercise books. The KPIs are the essential skills that a child needs to acquire in order to make progress in their learning and to achieve the expected standard. Each KPI objective needs to be evidenced with a date on which it was taught. The KPIs will help you identify the gaps in a child's knowledge and set their targets. A KPI should be highlighted to indicate that it's a target. It is also a good practice to get children to write their end of term test scores on the KPI sheet. All children should know their targets. The purpose of feedback in mathematics is to extend or consolidate pupils' learning or to clarify misconceptions. To that end, it is good pedagogical practice for teachers to draw a distinction between a next step question and a response question. So how do we draw this distinction? The purpose of a next step question is to extend or consolidate a child's learning. A next step question can be handwritten using a green pen or printed and stuck into a child's book. The purpose of a response question is to clarify a pupil's misconception or misunderstanding. So for example, if a child is repeatedly making the same mistake, it is highly likely that they have a misconception. This misconception needs to be clarified with feedback and should be tested with a response question. So let's look at an example of next step questions. So here we have an example of differentiated next step questions. This child was initially assigned to do question B, but because he managed to answer the question with relative ease, he was encouraged to progress on to question C. Now, differentiating next step questions has 2 benefits. Pupils are challenged according to their ability or stage, and there is opportunity for progression. How can we make our next step questions effective? It should be challenging. In other words, it should extend a child's learning, or it should consolidate people's learning. In other words, if a lesson contained multiple learning outcomes, then the next step question should encourage the pupil to apply all of the skills gained within that lesson. So here we have an example of a response question. When the teacher was marking the child's work, they realized that the child has a misconception because they repeatedly made the same error. The child was given some feedback and then was given a response question to specifically test them on that misconception. So how can we make our response questions effective? Well, before giving the response question, the child should be given feedback, preferably one-to-one verbal feedback about their misconception. And the response question should test the specific misconception. So for example, if a child has a misunderstanding about column method subtraction, then the response question should address that specific misconception. As you saw earlier, one of our goals is that we want our children to become fluent in the fundamentals of mathematics. In other words, fluent in arithmetic. And in order to achieve that goal, children need plenty of arithmetic practice, and that is why we administer an arithmetic test every Friday. All the test papers for your respective year group can be found in the arithmetic folder on the T drive. We request teachers to record the scores on a spreadsheet so that we can monitor the progress of the students. All of the test papers and the spreadsheets can be found in the arithmetic folder. On the White Rose Maths website, you will find the assessments. When you click on assessments, you will see that we have end of block assessments and we have end of term assessments. The end of block assessments are just mini tests that you can administer at the end of each block to assess children's learning of that topic block. However, the end of term assessments are administered at the end of each term and test pupils on the entire term's learning. There are 3 end of term assessments, one at the end of autumn, another at the end of spring, and the last is at the end of summer. Each end of term assessment consists of 2 papers, an arithmetic paper and a reasoning paper. Let's have a look at an example. So here we have the Year 3 end of autumn assessments. We have an arithmetic paper, a reasoning and problem solving paper, and we have the mark schemes. You will also find some spreadsheets that you can use to enter the pupils' scores and then perform a gap analysis using this document here. As teachers, it's really important that we ascertain what a child has remembered and understood from previous teaching. I'm going to show you how to use the primary maths progression map to accurately assess a child's learning. Now, every teacher has received a login to TestSpace. When you log into TestSpace, you will come to this screen. If you scroll down to Key Stage 2 Ready-Made Resources and you click on the primary maths progression map, you will come to this screen. Now, on this screen you'll see that topics have been organized here. We've got the topic headings here, and then for each topic heading you have this progression map for for the topic area, and you've got the learning objectives here for that particular year group. Now, for each learning objective, you'll see that there is an exemplification question for each objective. If we click on that, you'll see that we have a question and we have the answers, and on the left hand side you'll see that there are several questions for that particular learning objective. So these questions assess a child's understanding for that particular learning objective. Now, these questions can be used to exemplify progression over time. You can use them to highlight gaps or identify starting points. You can use these questions for your boosters and interventions. So to give you an example, let's say I'm working with a particular student and they are in year 3 and they are unable to do these questions for this particular learning objective. I can then get them to have a go at the year 2 learning objective for that particular topic area. We want to celebrate children's achievement in mathematics so that it engenders a passion and love for the subject. And that is why from now on, pupils who score at or above the 85th percentile in the end of term assessments will be awarded with a Maths Mastery Certificate. In addition to this, pupils who make significant progress in their learning will be awarded with an Outstanding Effort Certificate. and we will have a whole school maths day display that will celebrate their achievement. The impact of all of our efforts will be that our pupils will become fluent in the fundamentals of mathematics. They will be able to reason mathematically and problem solve, will possess a conceptual, a deep understanding of mathematics, they will be passionate about the subject, and they will achieve maths mastery.